Good afternoon, everybody. Thank you for joining us for the last session of the day. I realize it's getting late. Hopefully you've all had a coffee. We're here to speak to you about SharePoint 2013 and DPM 2012 and how you can use DPM to back up and restore your SharePoint data. So a little bit about ourselves. My name's Chris Whitehead, and I'm a Premier Field Engineer from Microsoft in the UK here. I'm also a Microsoft Certified Master, and some of my background more recently in terms of SharePoint 2013 is working as one of the PFE SharePoint Igniting instructors, and also I'm the PFE SharePoint EMEA Tech Lead, so I do a lot of stuff around our readiness and our IP for our engineers and our customers.
Hi everybody, my name's Sam Hassani. I've recently joined Brightstar, a UK consultancy firm specializing in SharePoint, to work as a SharePoint consultant. Prior to joining Brightstar, I worked in Chris's team as a SharePoint PFE, and for the last 9 months or so of that role, I was actually seconded to the product group to work as a beta engineer, and my primary focus was working with customers on TAP programs and other early adopter programs on beta versions of SharePoint 2013. So today we're here to talk to you about SharePoint 2013 and DPM 2012, and really take a look at how DPM can complement the out-of-the-box SharePoint backup and recovery capabilities. So the focus really is around DPM and looking at what DPM actually brings to the table, how we can set DPM up, configure DPM to protect our SharePoint data. We'll then look at how DPM kind of works under the hood. So Chris will kind of do a bit of a deep dive around that. We'll then look at actually restoring data in SharePoint using DPM. And then we'll wrap the session up taking a look at how DPM compares with SQL Server backups.
So just before we dive in, can I get a quick show of hands as how many people already have DPM? A few of you. Okay, cool. And how many people are interested in using DPM if they haven't got it? Okay, so it looks like you're in the right session. Perfect.
Excellent. Okay. So to start with, we thought it makes sense to kind of just do a bit of a recap as to what SharePoint offers from a backup and restore perspective out of the box. SharePoint 2013 doesn't really bring anything new in terms of out-of-the-box capabilities around backup and recovery. However, SharePoint 2010 did introduce a fair amount of new capabilities, some of which are listed here. So to call out the configuration settings backup, SharePoint 2010 allowed us to take a backup of the configuration of our farm and take these settings and put them into an XML file. This wasn't backing up the configuration database. However, this settings XML file could then be used to restore those settings to the same farm in the event that we needed to recover those settings. SharePoint out of the box also allows us to back up and recover all of our service applications. We can also take SQL Server database backups for most of our service applications. However, there are some pre- and post steps that we need to be aware of. But from a SharePoint perspective, we can back up our entire service applications, and often this is the preferred approach, as there are certain properties for our service applications that are stored within the service application object or the proxy itself. SharePoint 2010 also introduced the unattached content database recovery capabilities, and this really eliminated a number of steps when we wanted to recover a specific object, so maybe an item, a list, or even a site, from a content database backup that we may have had. So we'll talk more about this later and how this actually kind of is leveraged by DPM. In SharePoint 2010, we also had the introduction of several new PowerShell commandlets which allowed us to back up sites and lists and actually take advantage of SQL snapshotting, meaning that if we were to take a backup of a particular site, we no longer needed to lock that site as the backup was being taken, for example. SharePoint still doesn't allow for inline item level recovery. I mean, the content database, the unattached content database recovery feature makes things a little easier and saves some time. However, it still involves a fair few manual steps and a few things that you need to consider to actually recover items. And something which is still commonly misunderstood in the field from our experience is SharePoint backup and recovery of configuration central administration database isn't as one may seem. You cannot restore the configuration and central admin content databases unless when those backups were taken of those databases, your farm was in a stop state. So all services weren't running. The reason for this is you need to ensure that when the backups of those databases are taken, that your databases are consistent with the rest of the farm and the other databases in your farm. So we'll talk more about that shortly too. And this does bring us on nicely to DPM and some of the capabilities that DPM does offer. So inline item level recovery is one of the key wins for DPM, and we'll be demoing this very, very shortly. DPM does allow for configuration and central administration database restores, presuming that we do a full farm recovery, again, ensuring that we recover those databases in line with the rest of the databases in our farm. And the reason DPM does allow for this is that DPM relies on what we call the VSS, so the Volume Shadow Copy Service. And this allows a point-in-time snapshot to be taken of all of the content in our farm. And this guarantees the consistency of these databases. Several other things that DPM offers, so less storage required for backups, and again, Chris will cover that in some detail. Backup to the cloud, we can now back up to Windows Azure in the cloud and store our replication data there. We have role-based backup and recovery, so we can now actually delegate recovery of SharePoint content to our help desk, for example. And DPM does also protect other Microsoft products as you'd expect, such as Hyper-V.
Okay.
Looking at the limitations of DPM, very, very quickly. It's more of a misconception than a limitation. So DPM, we talk about the one-tick farm protection and protecting our SharePoint farm as a whole. And often it's misunderstood that DPM can't actually protect service applications in SharePoint. This isn't entirely true. Strictly speaking, it doesn't back up your service applications as part of the one farm tick protection. However, it does allow you to back up databases that are backing those service applications. And it also allows you to configure pre and post backup and recovery scripts. So, for example, certain service applications require certain pre-steps. So if you were to back up your search databases to protect your search service application, there's a requirement to pause the search service before you take the backups of those databases and then resume the service once the backups have complete. DPM would allow you to configure scripts that could handle that for you. So yes, there are additional steps that you need to take and additional configuration that needs to be put in place, but it is possible.
So now's the time to go through some of the additional things that DPM gives us. So speaking about SharePoint and the specific workload of SharePoint is obviously the focus of this session, but it's worth pointing out as well, for those of you that aren't aware, DPM isn't just a SharePoint-focused backup and restore product. It does pretty much protect the entire Microsoft stack. And any of the products you see listed here, be it Exchange and the mailboxes there, be it SQL Server and the underlying databases, or any of those other products can be protected by DPM. Additionally, you can do things like protect Windows clients, protect Active Directory. You can actually go and grab individual files and folders off of laptops, like remotely using the agent that will push that back to the DPM server. So it's kind of an all-in-one backup and restore solution. Sam mentioned you can push out to the cloud. You can also do what is traditionally what we call disk-to-disk backups. That's the standard type of backups we get in DPM, and then disk-to-tape as well. So you can go to disk first, and then you can go to tape later and set retention ranges and policies around that. And DPM will actually manage your tapes for you and your tape libraries and does all the cataloging and all the usual things that you expect for you. Another thing that you can do is actually use DPM to back up itself. So if you've got two data centers and if one of the data centers goes down, you may want to be able to bring up all of your backups as part of your DR strategy, and you can have a DPM server remotely that's backing up all of the backed up content in your live primary site. And of course, you don't have to worry about moving tapes and stuff across. DPM will do all of that for you as part of the backup over the wire. So question, we'll take that. So the question was, can you back up fast indexes? So you're talking about fast ESP? Yes. So the answer is no, not strictly speaking. There's no hook into that portion of fast. It's basically any Microsoft product that has a VSS writer is what DPM will support. And you kind of know about that if you read the documentation for each of the products, because Fast came from Fast Search and Transfer, the company. It wasn't traditionally a Microsoft-based product. So the answer is no. Obviously, in SharePoint 2013, the answer is, technically speaking, you can back up search with DPM. In reality, most people won't, because there isn't a kind of one-tick as Sam mentioned, backup option for search, and the options or the configuration for backing up search is a lot more complicated because you do need to use pre and post backup and restore scripts. So a little bit about DPM scalability before we move on. Basically, DPM scales massively. So it scales in terms of the way you can centrally manage it. So you can have up to 100 servers or up to 50,000 data sources, so various different clients or SQL servers and databases being managed by a single system center configuration console. So basically, rather than having to go to each DPM server individually like you had to in previous versions to manage all your backups, you can use one console now to basically manage all of your DPM servers. And then per DPM server, on a per server basis, you kind of get numbers that look along these lines. So 100 production machines per DPM server, or 3,000 Windows clients, up to 80 terabytes of Exchange data, 2,000 SQL databases, and 25 terabytes of SharePoint data. So what this means is if you had an existing 60 terabyte Exchange set up and you wanted to back up a 20 terabyte SharePoint farm or a couple of farms, you would need more than one DPM server. That's kind of what this is getting at, but it does scale pretty well for most organizations and the data requirements there.
Okay, so let's take a look at how we actually can use DPM to protect SharePoint data, some of the prereqs and configuration that's required. As I mentioned, DPM and SharePoint heavily relies on what we call the WSS, so Windows SharePoint Services, VSS, Volume Shadow Copy Service Writer. So a bit of a mouthful, and I won't go into the details around how the Volume Shadow Copy Service works. We'll take a look at this shortly. But what I do want to mention here is that SharePoint's VSS writer is a referential writer. And what this means is when the VSS writer, the SharePoint VSS writer is invoked, it in turn will invoke dependent writers, so the SQL VSS writer. And this technology is what allows us to take this point-in-time snapshot of all the content that we're protecting, which is why we are able to use DPM to actually protect our full farm, so our configuration database, along with our central admin content databases. So some of the configuration that needs to take place. Firstly, DPM 2012, you require Service Pack 1 to be deployed to protect SharePoint 2013. Once you have DPM set up, your server configured there, you first will need to configure your storage pool, which is where you'll have disk, which is where your data protection manager replicas and recovery points will be stored. You then need to install the DPM agent onto servers that you want to protect. So in SharePoint, you would need to choose a server to deploy this on, and this only needs to be one of your SharePoint servers. The way that we actually use DPM to protect SharePoint data is SharePoint isn't hosting any content that we want to protect, so SharePoint's almost just used as an entry point by DPM to protect the content that we need, which is actually stored on our SQL servers. So we need to ensure that we have the DPM agent installed on all the SQL servers that are hosting our SharePoint content databases.
And this is what Sam meant by a referential VSS writer. The SharePoint server is just that entry point that says you need to go to these SQL servers to get the content. So we don't actually pass the content via that server, we just use that server to find out where our content is. And then the DPM server speaks to the agents on each of the SQL servers in order to do the backup and the restore operations. Okay?
So the next thing we need to do is actually give permissions to the SharePoint VSS writer and the DPM agent on SharePoint servers to actually speak to our SharePoint farm. And we do this using a utility called Configure SharePoint. And this is deployed when you install the DPM agent on your SharePoint server. And we'll show you what that looks like in just a moment. Once you've done this, you're ready to go. So you can move over to your DPM server and start creating and configuring a protection group. A protection group is just a logical container containing data sources that you want to protect using DPM.
The way to think of a protection group is kind of like an SLA. So you say, we want to protect these servers with these policies, these SLAs for backup and restore. That's all it is, okay?
So this is the Configure SharePoint utility, just a screenshot of what that looks like running in a command prompt window. All you need to do is run the utility, supply the credentials that you want the VSS writer to use, and away we go. Once everything has been configured correctly, and you'll know things have been configured correctly, when you move over to your DPM server and you navigate to your SharePoint farm or the SharePoint server as to where you've actually deployed that DPM agent, you should now see your SharePoint farm available to be protected. So you can see on the slide here that the farm is actually represented underneath a SharePoint icon with the configuration database name. So this is the one-tick farm protection that we mentioned. Selecting that entry there will protect all of our SharePoint content. So you can see we've got some content databases in this example hosted on a couple of SQL servers there.
It's also worth pointing out that obviously you can see all shares, all volumes, SharePoint and system protection, and that just indicates that there's various VSS writers available on that server, which means there's various different products or Windows pieces of functionality that are available. So there's a file system VSS writer, if you like. There's the system protection, which is basically the system state of the machines. If this was a SQL server or if this was an Exchange server, you would see the option to protect the databases or mailboxes and so on and so forth.
Exactly. It's probably also worth mentioning here that we have this one-tick farm protection. You can see in this example as well that we have a SQL server listed there, SQL 2, and you could expand that node out and attempt to protect additional databases. However, the DPM server here wouldn't allow you to actually select content databases that are already protected by the SharePoint farm that has been selected there. So if you were to add additional service application databases, for example, you would be allowed to do that because they aren't covered by the farm protection that's created here.
We'll show you that in a demo in a minute as well.
Absolutely. So at a high level, let's take a look at the data flow when a backup is requested by DPM. So in this example, we have our DPM server down the bottom left-hand side. The DPM will communicate with our SharePoint server to request a backup to be taken via the DPM agent. The DPM agent on the SharePoint server will invoke the VSS writer, and the VSS writer here on the SharePoint server will in turn invoke the VSS writer on the SQL servers. And this will allow a point-in-time snapshot to be taken of all of our content. Once we have that content, it's replicated back over to our DPM server. As you can see here, the final activity that's carried out is this cataloging, and this cataloging activity is where DPM actually collects a catalog, essentially, of all of our sites, lists, objects within our SharePoint content hierarchy, which DPM will use when we need to perform recoveries and so on, and we'll show you what that looks like in a demo.
So when you think about using DPM to do restores, you need to know what the farm looks like in order to drill down and click on that document library or that particular document, and you need to know what it looked like at the point in time you did the backup to be able to restore that content, right? So DPM does have to do its extra job where it goes and finds out what the farm looks like at that time. So you can say, right, that document there, I need to restore that one. Okay.
So if you imagine the scenario that we create additional content databases, how does DPM handle this change? So here, we add another content database to our SharePoint farm, and we've actually added that database on another SQL server. So DPM can actually automatically identify this topology change. So the next time it actually carries out a backup, the VSS writers will recognize this. So again, once that request is made, we speak to the DPM agent on the SharePoint server. The VSS writer will be invoked on the new SQL server with the new content database and start protecting the data over there. One thing to call out, in case it wasn't very obvious, was that obviously for this to happen automatically, the only thing that we need to do as a prereq there would be to deploy the DPM agent on that new SQL server.
And you could do that either as part of the build of the server, it's just an MSI, so you could actually push it down with AD, you could use System Center Configuration Manager, any of the things that you tend to use in your org, you could use to push that down to the server as part of that build.
And then obviously the cataloging activity takes place at the end of the backup. So let's flick over to our VMs and see what this all looks like. So I've got a few virtual machines in this environment. I have a DPM server, SQL server, and a SharePoint server. So over here on my DPM server, This is the administration console for DPM, in case you haven't seen it before. You can see there's 5 main areas here. We have a monitoring area, protection, recovery, reporting, and management, so all fairly self-explanatory. We'll take a look and call out some of the key areas here. So within management, you can see that we kind of have some sub-areas. So on the left-hand side here, we have agents, disks, and online. So online there is referring to the Azure Cloud Backup option, which we touched on. We have agents, and from here, we can see servers as to where the agent has actually already been deployed. And we can actually remotely install agents to other servers within our environment. So if I hit install there, got the install agents option, and I can see other computers which are available for the agent to be deployed to. So I'm not going to go through this process now, as we already have deployed agents to everything that we need for the purpose of this demo. You can see within the disks, we can see all disks attached to our storage pool. You see that I actually have 2 disks here within my DPM storage pool, and the way that you actually handle this is you need to present the disk to DPM as a raw volume, and then DPM will handle the disk and do what it needs to do with the disk. So in this particular example, if I flick over to disk management, you can see the 2 disks here, and you can see DPM's created its own volumes with nice GUIs appended and whatnot. And as you create additional protection groups, and as more and more replicas are created, you'll see DPM automatically carve up volumes in the unallocated space here.
So the way to think of this is a big load of disks that DPM just needs to have access to. The more you add, the more data that you can back up in theory, and then DPM just does all the magic of carving up the disks for you. So every time you do create a protection group, like Sam mentioned, it will carve up a certain amount of data on the disk that it will allocate to that protection group. And if it needs to expand the size of that, it will do dynamically as well.
So if we flick over to the monitoring area here, monitoring is divided up into 2 sections. We have alerts and we have jobs. So alerts is quite useful as it kind of gives us an indication as to the overall health of our DPM server. If there are any issues with protection groups, you can see here that I've got a few warnings, a few informational messages too. Nothing of major concern there right now. Within jobs, you have different views, but this is pretty useful to kind of get an understanding of how long particular backups are taking. If you're waiting on an object to be recovered, you can come here, have a look at jobs in progress, and use this almost as a reference to see how long particular activities have taken. Over to protection. This is where we can create our protection groups. So what we'll do now is actually go through the process of creating a protection group. What you might notice here is that we actually have an inactive replica available. So previously, we did have a protection group created for our SharePoint farm. However, we've removed the protection group, but we've maintained the replica so that in this demo now, when I go through and create a new protection group, I can associate the protection group with this replica that was previously created. Otherwise, we'd be waiting a while for that replica to be set up.
And I'll speak a bit more about replicas and kind of storage areas in a minute, but basically the way to look at the way DPM works is that it creates a one-to-one replica of your content at all times. So it will say, give me all of your databases, let me have this replica of them, and next time you do a backup, it takes the changes and synchronizes them into that replica. So it always has like a live replica of the content, minus the time since the last backup, obviously. And that's what we mean when we talk about replica, just so it's clear. And I'll talk about that a little more in a second.
Okay, so what I've now done is I've just selected the new protection group option from the ribbon, and it fires up a wizard, which I can walk through. It mentions that there's 2 kinds of protection groups, servers and clients. In this case, I'm protecting a server, which is my SharePoint environment. I can now see available members, so I can select the data that I want to protect. I can see my SharePoint server here, and it will just take a moment to build that out as it goes over and communicates with the DPM agent that is deployed on that server. And you can see here, we have SharePoint, and we have the farm denoted by our configuration database name. What I will show you is if I expand out the SQL Server here, which is backing my SharePoint farm and hosts all of my content databases and service application databases, if I expand this out and I attempt to select a content database which is part of my SharePoint farm, you can see that I have an error fired up saying that I can't protect this selected database because it's already protected as part of a SharePoint protection group. What I could do, though, if I wanted, would be to select some of the service application databases, but I won't do that now. Obviously, to protect those, I would need to configure pre and post backup and recovery scripts.
And you don't, when we say pre and post, you don't have to do that. You can still protect your service applications just as SQL backups, if you like, SQL workloads, as we would call them. It just means that once you've restored the database, it would be akin to manually restoring a database from SQL, but having no proxy or no service application actually configured in SharePoint. So you'd have to actually go and create a new service application in SharePoint, but specify that database as the one that you're going to use rather than creating a new one. And that would create that service application with you and attach that database. As Sam mentioned, though, there are some settings that quite often get stored in the proxy config itself. So you may still want to do a backup of the proxies in your farm if you are manually protecting your service applications in this way. The pre and post backup and restore scripts would just allow you to automate that a little more, so you could do some PowerShell wizardry to go and get the proxy groups and back them up and restore and so on.
Okay, so now that we have our SharePoint farm selected, I'll continue through the wizard. I can give it a name. I can select the protection methods. So do I want to protect using disk? It's the only option I have available here. I haven't configured the online protection. I haven't configured any tape management as of yet. So I'll keep the default options there. I can now specify the recovery goals for this protection group. So the retention range, the schedule for the express full backups, and by default, this will always be at 8 p.m. For SharePoint content, we can configure this up to every 30 minutes, should we have that requirement. Keep the defaults for now.
We'll speak a little more about how often you should or shouldn't do backups and the way DPM works in a minute, and it will become clearer as to why you may not do more than one backup a day. For the retention range, obviously that is what it says. It's basically how long it will retain the data before it deletes it. You can, of course, if you've got tape libraries configured, say retain on disk for X days and then move to tape after a certain amount of time. It's not, set in stone. You can customize this. And that's what I meant by a protection group really being an SLA for your backup and your backups. It's what settings you want to configure around how long your backups are retained, how often they happen.
Okay, and now I kind of have the option to review disk allocation. So just a few options around how DPM is actually going to store the data in the storage pool. Am I happy for my data to be co-located alongside other data in the storage pool for other protection groups? I'm happy for DPM to manage how these volumes are going to be growing, and I will again keep the default options here. Again, how's DPM going to create the replica here? Do we want this to happen now? Do we want this to happen at a specific time? Maybe creating this out of hours would be a good idea to reduce the amount of bandwidth that's going to be consumed during the day.
And a good thing to point out here is if you had a large farm and you were protecting it for the first time and that replica was being created, you wouldn't necessarily want to transfer a few terabytes over the wire during production hours. What you might want to actually do is select the manual option, do a standard SQL-based backup of the databases, restore them to your DPM server, and then point DPM to them, and then DPM will actually synchronize any changes since they were backed up and since you start the protection. So it's a more manual approach, but you don't have to do everything over the wire if you don't want to, which is probably a big problem for a lot of people.
And then the final options around the consistency check. So again, I don't want to take too much away from Chris is going to talk about later on, but you can configure as to when a consistency check will happen to make sure that the replica that we're hosting, which is of our SharePoint content, is in sync with the real live SharePoint content that we have, ensuring that everything is maintained there. So we'll go ahead and create this group. And it's telling us that an immediate consistency check will be performed. And the reason for that is that we already have this inactive replica. And if we want to use this inactive replica, we need to ensure that a consistency check is performed to gather any differences. So we'll apply the changes, and we'll allow this to go ahead and create. You can see there that I selected the UPA social database and didn't deselect that. So it's going to go and add that to the protection group, but for the purpose of this, it doesn't really matter. Okay, so just quickly to show you, I think that's kind of all happened pretty quickly there, but if we came over here, over in monitoring and jobs, we can see that there's a number of jobs running. So all the databases that we're protecting, we have individual jobs to carry out the backup there and create the recovery points once the backup's actually completed. Okay, anything else to show here?
Nope, I think that's everything.
Brilliant.
Okay, so you're probably wondering, that's great, that's how we do the backup, but how does this really work? What does DPM give me that another product doesn't already give me, or that SQL backups don't already give me? So I'm going to talk through how DPM works under the hood, how it does incremental backups versus full and differentials, what the replica is, and what the actual kind of area that we store these backups is, and how that all works under the hood. So if we flick forward, the first thing to think about here is that DPM, as Sam mentioned, has this agent, and DPM knows what blocks on the physical disk make up our content. So if we look at the SQL Server 1 diagram on the left there, we've got a number of content databases and the logs that make up our content for our farm. And DPM, via the agent, actually knows what physical blocks on the disk of those servers contain that data. So what happens is it actually monitors those blocks, and when a change occurs, that DPM agent, using a filter, will actually do something to keep a record of what's changed, so it knows what it needs to send over. And it does this by creating a volume bitmap in memory. So in page pool memory, it will actually create this small little volume bitmap, which is a 1 and a 0, basically, for every single block on disk. Now, it uses very little amount of memory, but it will actually just flip a 1 or a 0 over to say, right, block 22 changed, block 900,000 changed. And it's obviously one block at a time. So if a file is made up of 400 blocks on a disk, when it changes, we flip 400 little bits in memory, we store that, and when we come to do a backup, it knows the exact blocks that need to be synchronized over to the DPM server. And what I'm going to do is I'm going to walk you through the way that works and the way it looks under the hood. So you can see here we've got that DPM filter, the volume bitmap in memory on the right. This is on the server being protected. So this is on our SQL database, our SQL server at this point in time, okay? And we call these synchronization windows. So between the period of an express full backup and the next one would be a sync window. So the way to look at that is we've done an express full backup at some point in the past, and between now and the next time we do an express full backup, we need to keep a track of all the changes that are happening. We need to be able to store them somewhere in that bitmap and then sync them over during that window at the end over to the DPM server. And what happens is, let's say we take the database here, content DB1, and we break that down into blocks on the disk. So these are the physical blocks on that disk. And at 10 o'clock, we do a file write. So a file changes, a Word document, for example, gets written as a blob into our SQL database, and we change the physical bits on the disk, updating the content within the database. What happens is the DPM agent will actually keep a record of that. It will note those blocks that are being changed just by flipping a few zeros to a 1. Again, at 10:06, for example, the same thing happens. Another file changes, so we make the changes on the disk, and we flip the bits in memory, extremely efficient, on the server that we're protecting, not on the DPM server at this point, remember. Again, a third change happens at 10:18. We make the change, we flip the bits, and it continues as we continue to make changes. Now let's just say that we've got an express full, a backup, configured to happen at 10:30. When that express full backup starts, that's when we start to send the data over to the DPM server. So at 10:30, we take a VSS snapshot. So we actually freeze all the blocks on the disk on the left, and we say, right, this is what the disk looked like at this point in time. And then we start sending the blocks over to the DPM server via the agent. In the meantime, we can actually continue writing to the disk whilst our backup's occurring. That's what VSS gives us. It's extremely efficient for backup. It doesn't mean that you have to have the disk at, take the farm down, take the database down to do the backup. It's kind of the way SQL does its backups already under the hood. So what happens is synchronization starts, express full starts, and we actually send those blocks over to the DPM server. So they start getting sent over the wire. In the meantime, whilst those blocks are sending, we make some more changes. So they're still going. It could be hundreds and hundreds of changes that have happened. And in this case, we add a few more blocks, and we change some blocks, on the disk, and we store that in the bitmap in memory to keep a record of it. Because obviously, we need to now know what blocks have changed since that synchronization window started again until we do our next backup. And file I/O just continues. We continue to write to the disk, and we continue to store a record of what's changed since we started our backup. Then what happens is the synchronization window ends. So we've completed our backup for everything from 10 o'clock to 10:30, and we actually release the snapshot. So we delete the snapshot, and we reset the bitmap. But we keep the 5 blocks here that changed since our backup started. Because when we do our next backup, we now need to say, all right, those blocks have changed. We need to synchronize them over. Okay? So that's what happens when you're backing the data up. That's what happens when you're saying what's changed, what needs to be sent over to the DPM server. But how does DPM work in terms of actually storing that data on disk? And how does DPM work in terms of actually having a production replica area and then an area where you store all those individual recovery points, all those little changes that have happened? So in this scenario, we've got our production data on the left there. That's our content databases. And we've got our DPM replica on the right. And as I mentioned, our DPM replica is a one-to-one replica of all of our SharePoint content. So if we have 100 content databases, we'll have 100 content databases stored on the DPM server, and they will always be in sync pretty much with the live farm. Obviously, they're only going to be as in sync as the last express full. So if we've just done an express full, we'll have a one-to-one replica like you would if you had just done a normal backup. The only difference is if we were, say, 1 minute before our next backup, we'd obviously have all of the time window back to when we did our last backup. That's the only way it's different, okay? So we've got our original data here at 10 o'clock, and our production data was the same as our DPM replica. And we make some changes at 10:15. So our production data gets updated, and as I just showed you, we've stored those bits in memory, and we're going to send them over to the DPM server at some point. And what happens is, that point comes along, we do an express full, and those blocks get sent over like I showed you in the diagram. But on the DPM server, we actually push those blocks into the replica area, and then we displace the blocks, as they did look, into a recovery point area. Because we need those old blocks, we need to know what they look like if we want to go back to CNF, for example, in this scenario at some point in time. So we push them down into the DPM recovery point area, which is a separate volume on the disk, so we can go back to that point in time if we need to. Some more data changes at 10:52, and we push those blocks over to the DPM server the next time we do an express full. They get pushed into the replica, some blocks get displaced, and we continue this over and over and over during every synchronization window. It might be that our data files expand, we get more data added. Again, we're just pushing those blocks into that replica, displacing the changes into a recovery point area. So now you think, well, what happens when I want to do a restore? Well, this is actually quite simple. If we wanted to go back to, say, 11 o'clock, what we do is we take all the blocks as they looked at 11 o'clock. So in this scenario, it's everything except for the red ones, right? So we just play back the blocks from the replica area and the blocks from the recovery point area. And that's what our farm, or that's what that particular item looked like at that point in time, okay? If we want to go back to 10 o'clock, then it's really simple, right? We just play back all the orange blocks, because that's what the farm looked like, or that's what that particular document even looked like at 10 o'clock. And that's the way DPM basically works under the hood. So VSS to do the snapshots with this volume bitmap in page pool memory, and then on the DPM server, really efficient storage on the disk by only pushing in the blocks that have changed into that replica, and then pushing the changed items from that replica down into this recovery point area. Is there any questions on that so far? Okay, so I'll repeat the question for the benefit of those that couldn't hear. I'll summarize a little bit, but you're basically asking if when you've got a pre-sized database to say 100 gig and you've only got 20 gig of content, will DPM back up the whole 100 gig versus just the 20 gig like a SQL backup would? I believe it will back up, as your experience is, the database as it looked as a 100 gig item, because basically it stores not a backup in the replica on those volumes. It's actually the full data file and the transaction log. So it's going to be as big as what it is on the production system. That's why. That's just a kind of caveat of the way the storage works for that.
Yeah, that's why that just means that that's kind of a limitation.
Yeah, it's a limitation of, I wouldn't say the VSS writer, it's a limitation of the way the data is stored in the recovery point area and the replica area. Okay, any others?
Okay, so let's kind of take what Chris has talked about in terms of how we can actually recover data under the hood in DPM and apply that to SharePoint content. So if we consider a SharePoint content database and we want to recover that entire database back into its original location over an existing database, how does that actually work? So on our DPM server here, we initiate the recovery of that database. The database will be restored directly onto the database server as you'd expect. You'll then see that there was a request sent over to the SharePoint server there, and that request is to tell SharePoint to refresh its site map. The site map is a very important table in our configuration database, which lists out all of the SharePoint sites which exist in our SharePoint environment. So that refresh of that site map will just ensure that all of the sites that exist in content databases is actually reflected truly in the sitemap. Alternatively, we could actually restore that database to an alternative location on a file system on another server. Maybe useful for testing purposes to have a copy of that database. It might be an old backup that you want to try something out on an old site. You may want to try something on a different version of a particular site, pre-upgrade, for example. So if you think now around content within a specific database, so sites, lists, and items, how does this work? So in this case, we are using the SharePoint object model for recovery of all of our objects here, all types of content. So what we are really using under the hood is the content migration API. So internally we refer to this as the Prime API. You may have experience with this, but it's the same API that's used by our import and export commandlets with STS-ADM and now PowerShell for the equivalent commandlets. And we also take advantage of the unattached content database recovery capabilities within SharePoint. So if we imagine here that we're restoring a particular item, or we want to restore an item, the first thing that happens is we restore that database, and that database can be restored to a SQL server within your SharePoint farm, or it could be a SQL server somewhere else. In this example, the SQL server is in our farm. It doesn't really matter. The database is restored. Then we use the unattached content database recovery capabilities to drive into that database. Remember, the database isn't attached to your farm, and we export the particular object that we're after. And that export will create a content migration package on our SharePoint server. We can then take that package, and it's restored into the desired location. And there we have it. So that approach works well, and that's how things happen in DPM 2010. But slight problem with that approach, or maybe inefficiency, more so than a problem. Imagine that you just wanted to restore a 10K Word document, but that document lived in a database which was 200 gig in size. Obviously, the storage requirements need to be there. You're going to have to wait for that database to be restored over the wire. Not really the most efficient approach to take. So the way DPM 2012 actually works is, what it does is, the replica that exists on the DPM server is exposed as a share. We can then remotely mount the database on the SQL server, and through that means, again, using the unattached content database recovery capabilities, create our content migration package. From there, the process is the same. We can restore to the desired location.
So those of you that had DPM 2010 would realize that it'd take quite a long time to restore an item because of that requirement to restore a database. With 2012, it's literally seconds because we don't restore that whole database. We just mount it over the wire and we just communicate with the remote SQL server from a DPM. Sorry, the SQL server communicates with DPM remotely, pulls out the content that it needs over the wire, creates that prime package and pushes it back into SharePoint. And it's a matter of seconds, literally, compared to what would be up to a few hours if it was a multi-gigabyte database.
So there is one other scenario to consider. The content migration packages that we create, we can only restore these to a farm of the same build as to when that migration package was created. So if you imagine the scenario where a backup was taken one day last week, over the weekend, you apply a service pack to your SharePoint production farm. The following week, you want to actually recover some items from that previous backup that was taken. The migration package that would typically be created from that backup would be a different build version as to what your production farm was currently running. And it's not supported to restore those migration packages in that scenario. So how does DPM handle this? Well, we use a recovery farm in this situation. The recovery farm is used to actually upgrade the content database as to where the content that we want to recover lives, update the schema, and then create a new content migration package which would be supported to restore to our current production farm. So the key thing there is that recovery farm will always need to be running at the same build level as your production farm so that upgrade can happen. And the way this all kind of ties together, and obviously DPM will handle this for you automatically behind the scenes, is the database is restored to the recovery farm, and this could just be a standalone SharePoint server running SQL. It doesn't need to be a fully fledged farm. Once the database is restored, it's attached to SharePoint. So for those of you that have been through upgrade scenarios, you'll know that when you attach a database to SharePoint, which is an earlier build version, upgrade will be invoked on that database. So the database is then upgraded. At that point, our database is at the desired level. We can export the particular object that we want, a list, a site, create that content migration package, move it over to the production SharePoint server, and then restore it to the desired location.
Now that seems really complicated, and it is, but that's what you have to do anyway, even if you don't have DPM. So if you're using SQL backups now, and you restore a database backup from a year ago, say, and you've installed Service Pack 1 since then, or whatever the service pack, and the CIO says, I need this document that was in my site from a year ago, you would need to restore that database to a SQL server, attach that to a SharePoint farm that was at a higher build than you're currently on, which would do an upgrade of it. So it's quite messy. That's just a SharePoint limitation. It's not really DPM's fault. DPM just has a way of automating the upgrade, if you like, automating those steps so you don't have to do them as an admin.
Okay, so let's take a look at that in practice. We'll flick over to our virtual machines here. So I have a SharePoint site, and I have a document library with a few documents in it. One of the items within this library is just an image, an About Us image. If I open that, you can see it's one of our default stock SharePoint images. What I'm going to do is delete this item, and then we'll use one of our pre-created recovery points to restore this item. So if I delete that, send it to the recycle bin, you can see it's moved from the library. I'll now go to our recycle bin and remove it from here. I'll go to my second stage recycle bin and remove it from here. How end users accidentally do this deletion 3 times will never cease to amaze me.
We've all been there, right?
Okay, so everyone happy that that's gone? It's out of SharePoint, right? Okay, so flick over to DPM. And if I dive into my recovery area, you can see there's actually 2 ways within this recovery area to identify content that we want to restore. We can either search for content using some parameters here. So I can zoom in and show you. I can specify a site name. If I know the document name, I could type that in. The site that we were on there was called DPM demo. If I search for that, you can see several results. We have the same site there listed 4 times for every backup of that site that was taken with an associated recovery point, specifying the date and time. Alternatively, I can actually browse for the content that I want to recover. In order to carry this out successfully, I'll need to know exactly which content database a particular object that I want to recover resides in. So I can use the calendar here to choose the date that I want to go back to. So let's go back a week or so to the 8th of April. I took several backups on this day, as you can see. I'll go back to the first backup that I took, as I know that was a good backup. Drill into the database here, WSS content SharePoint. I know that's where this particular site with the image that I want to recover lives. My DPM demo site collection there. Drill into the documents library.
And this list is stored in a database on the DPM server. So this is that catalog that occurs, and DPM creates this list that's searchable via the user interface here or by drilling down. Those of you that have used DPM will notice that if you've just done a backup, that catalog isn't available straight away. You can't drill down within a few hours normally. And that's because the catalog job runs kind of a bit like a SharePoint timer job in the background after a couple of hours. And then magically, you'll be able to start drilling down into your content. And that's just a SQL agent job that runs on the DPM server.
If you ever need to force that cataloging to take place sooner, there is a PowerShell command that you can run to make that happen on demand.
Yeah.
Okay, so I found the image that I want to recover here, the About Us default PNG. If I hit recover on the ribbon, I'll whiz through the wizard, just conscious of time here. Got a few options. I can recover to the original site, recover to an alternate location. I'll go with the default here. You can see here, it gives you two options around using a recovery farm or not to use a recovery farm. So if this backup was taken on a previous build of SharePoint before, say, we applied a CU or a service pack, we'd obviously need to go for the second option there.
It's also worth pointing out that if you're not using a recovery farm, the default with 2012, like Sam said, is that we remotely mount that database to do the faster optimized restore. It's called optimized inline recovery on the marketing speak. If for some reason that fails, it fails to do that remote mount, it will automatically fail back over to the approach of manually restoring the database to the SQL instance and then extracting it. So it's kind of clever the way it works.
Okay, so now I specify the SQL instance that I want to use to temporarily stage this content database, or in this case, remotely mount that content database, which hosts this particular item that I want to recover. So I'll select my SQL server here, hit OK. I can now choose the specific location on this server and the file system as to where I want this to live.
So you specify the location here, because obviously we are remotely mounting, so in theory you shouldn't be writing to the disk, but we do specify it here in case it does fail back to that second option, and then it will write to this.
And it does actually need to carry out a full restore of the database. I now need to specify a location on the SharePoint server as to where that content migration package is going to be created. So it provides me the means to drill into the file system here, select a directory. I have a pre-created folder there called DPM, which I've selected. I now have a few options, so I can choose to maintain the security settings that were already associated with the particular item that I'm recovering. So again, kind of similar options that you see when you use Prime API through PowerShell or other means. Network bandwidth usage throttling. So again, I can specify if I want to throttle the amount of bandwidth that's going to be used if I'm carrying out this recovery during the day. Enable SAN-based recovery. So if I have a SAN which supports snapshotting, I can do this. Obviously, some further configuration will be provided at the back end. And finally, some options there around notifications and alerts to notify an administrator when the recovery completes.
And all of this can be done in PowerShell as well, so you can script out restores, as easily as you want.
So I'll hit recover there. You can see this is kicking off. I can close this window. I don't need to keep this open. And if I move over to the monitoring tab, let me just refresh this. You can see that there was a couple of jobs there. It all happened pretty quickly. So if I go to completed, hopefully we'll see here there were 3 jobs actually. all associated with the recovery here, which hopefully is today's date and time. I think that's about right.
Notice they took seconds. It was really quick to do that remote mount and that restore.
So now, if we flip back over to our SharePoint site and visit our document library, you can see already that the About Us image is back in there, modified about a minute ago. I can then go in, open that, and there's the image fully restored in a matter of seconds.
Question. During this process, you lose the metadata information, like the creator and version history? Or is it still like it was before? Because now it's modified about a minute ago. You lose the information when it was first created.
Yeah, so it's the same as what it would be if you do an export and then an import. So there are some limitations, and I'm going to speak about that on the next slide. Just to repeat the question, it was, do you lose the metadata and some of the stuff associated with the item? Yes and no. So, for example, when you use export and then import out of the box with the command alerts, you lose certain things like the state of the recycle bin. So if this was a site collection we were restoring, when you've done the restore, you'll notice that there isn't actually any content in the recycle bin. And there's other things that you lose, like in-flight workflows and so on. So it's not the golden bullet in terms of, or silver bullet, sorry, in terms of, the best restore mechanism, but it's what SharePoint offers. It's the only API SharePoint offers to do restores.
And it's the same API that we leverage when we do an export SP web, for example. So security settings, versioning, so versions of documents will be retained.
Yeah.
But there's certain metadata properties that won't be maintained, such as recycle bin state, workflow state, and so on.
But obviously the date modified will be changed in this scenario. Yeah. Okay. So we touched on it briefly. There's a few points about recovering SharePoint data. First one is that if you do need that recovery farm, then basically you just need one web application, and that web application needs to be called exactly this, the DPM recovery web application, because that's what the DPM server looks for when it does that attach. So it basically tries to attach the database to a web application called this. And this could be on a pre-production farm, it could be anywhere, and you just install the agent on there as well. And there's a few extra options that you have to specify in the wizard as part of the steps, and it just pushes directly to there as part of the restore. A couple other points. If you do a full farm recovery, we didn't show that today because it's quite a long demo, you can actually just choose the option to restore everything in your farm, and that will everything means all your content and your config and your central admin content database. If you do a restore of everything, you need to make sure that the servers that you're restoring to have the same names. Because if you do restore the config DB, it contains the names of the servers in your farm. So if for some reason your data center fails and you don't have a HA solution for failing over to another SharePoint farm, and you need to rebuild, when you do a restore of all those backups, the databases will have the data or the details of the servers as the farm looked when you started out. So if you think it's a good time to start renaming your SharePoint farm, it's not. It needs to be created in the same way. Is a question?
Would all those machines have to be in place to do that full farm recovery?
So would all the machines have to be in... So yeah, the question was, would all the machines have to be in place to do the full farm recovery, or it's just a subset? Strictly speaking, no, because DPM doesn't know what is there and what isn't. All you need to really have is one server with the same name, DPM agent installed, and when it does the restore, off you go. But when you think about it, it would be like having your config DB with servers missing from the farm. So it would just be like a server was all of a sudden missing from the farm. So you could do that. Ultimately, you'd want to get them all built, or you'd have to remove them manually from the farm at that point. Okay. And then there are caveats of export and import, which are the standard ones, and these are all listed on TechNet in addition to the ones we mentioned. Okay. Another question? Yes, the question is, do you need to recover a full database if it's a different service pack? And the answer is yes, because you need a recovery farm. So the reason for that is the database itself will be at a certain build number, and you can't connect into the database to pull the data out from a farm that's on a higher build number. So you need to bring that database up to the same build number by mounting it into a farm that's at the same build as the production farm, and then it will export. In theory, yes, you could need several recovery farms. If you had multiple SharePoint farms that you were protecting with DPM, and they're at different builds, then you would need several recovery farms. In theory, you'd only need one at the highest build that you're on to match your production SharePoint farm. You wouldn't need one for each service pack that you've installed, because you always want to upgrade the database to whatever your current production farm is on. You'd never upgrade it to some lower number. Yes, you would do at some point probably need a recovery farm. Can we hold questions just to the end so I can just get through the last 5 slides and then I can let people go that need to, because I'm conscious of the time. Thank you. So 3 or 4 slides really quickly. Just going to talk about DPM versus SQL Server Backup and why one is better than the other. If you think about SQL Server Backups, we might have 250 gig of content databases here in SQL. So when we back them up, if we do a full, then in theory it's 250 gigs worth of backups, right? Now, if we do a backup and we assume we get 70% compression during that backup, which is quite a lot of compression, in reality it's not going to be anywhere near that number, but let's be generous for the sake of this. That will give us these figures here in terms of the amount of storage required to store those backups for every full that we do. So we're looking at 75 gigabytes per backup for every full backup. Now for this scenario, I'm going to assume that we're doing a full backup every night. In reality, yes, you might be doing differentials for a week, for example, but with differentials, the numbers soon start to add up to quite near that number anyway. That means for 2 weeks, 75 gig times 14 days would mean that we need 1 terabyte of storage to store 14 days worth of full backups for all our content databases. So a fairly significant amount of storage straight away, assuming quite a high compression ratio. With DPM, we've got those databases, and we've got that initial hit of that 250 gig replica. So on our DPM server, we need those disks with that storage pool. So we're using 250 gig straight away, and it will be the same number as the farm. So the farm grows to 252, it will go up to 252, right? But what we get here is if we were to assume a 10% data change churn, a churn rate per day, so our farm's data and all those databases is changing by about 10%, we get 10, 5, 4, and 6 gig respectively. That gives us a total of 25 gig per day, and we times that by 13 days, which gives us 375 gig for our DPM recovery point area. So our replica, the area where we've got our replica in, is 250. Recovery point area is going to be 375 for 14 days worth of backups, basically. 625 in total, okay? So we're just over half of what we would be doing if we were doing a SQL set of full backups. If we were to say 5%, so that's changed to 5% now, we'd be doing 12.5 gig a day of data change, which is probably a lot more realistic for a production farm. Numbers are going to vary, obviously. And that pushes that number down to 418 gig. So we're actually storing a lot less data from a backup perspective with DPM because we're only sending over those little incremental changes, the block changes on the disk. We're not storing full backups or differentials, which contain repeated data over and over, okay? So over a period of months and years, if you had to store all this, yes, tape's cheap, but DPM will actually not only make it more efficient in the short term on disk, when it goes to tape as well, it'll be efficient too. So you'll be saving a lot of money in storage, be it disk or tape. And that's a summary. I won't read through that, but if there's any questions that anybody has, now's the time to take them. Thank you.